Okay, in the following examples, we're going to go from rectangular form, so a plus bi, to complex form, which is this r cis theta. So we're going to go from a plus bi to r cis theta. We're going to go to trigonometric or polar form. Okay, so we're given a couple of examples, and we're going to take a look at this first one that we call number 6. We're going to say 3 minus 3 square root of 3i. Okay, so this is a bit of a process. There's quite a bit to work on. We've got to look at this little table here. But first thing I suggest we do is visualize where is this in the complex number plane. So let's go ahead and just give a rough sketch. We know that the x part is positive and the y part is negative. Okay, so the x part is positive and the y part is negative. And I'm going to put the I out here just so it looks a little bit better. All right, so if x is positive and y is negative, then it's going to be living somewhere out in this direction. This vector here would probably be close to representing what it looks like. So what we're going to do is we're going to think about, well, how many degrees would be in a rotation that looks like that? Okay, so we're going to have between 270 and 360 degrees that we're working with. Okay, because we end up in quadrant 4. So we're in Q4 here. Okay, so in Q4, quadrant 4, our angle will lie between 270 and 360 degrees. Okay, so let's kind of keep that in mind. Now what we're going to do is we're going to find the r component, the modulus, if you will. And the r component is going to be the square root of x squared plus y squared. So let's find r. We're going to say 3 squared plus, and then it's going to be negative 3 square root of 3 squared. Look, something like that. And that's going to be a square root of 9. And plus a negative 3 squared is 9. And a square root of 3 squared is 3. So then you have 9 plus 27, which is 36. And the square root of 36 is 6. So our r in this case, r equals 6. Now what we're going to do is we're going to come up with the angle theta. Okay, so now to find the angle theta, we're going to have to use this formula right here. The tangent of theta equals y divided by x. So what we're going to do, I'm going to write that down first of all. Tangent theta equal y divided by x. And then I'm going to figure out what my y and my x are. Well, it's going to be negative 3 square root of 3 over 3. So this is what the tangent of theta would equal. So this right here is negative square root of 3. So now we must recall that we are looking in quadrant 4 for a tangent value that would look something like this. Okay, so our job is going to be to go to the unit circle. So let's go ahead and do that. All right, so let's see here. Where would tangent, which is y divided by x, equal negative square root of 3? So that would imply that we are looking at this right here at 300 degrees, because if you think about it, y, negative square root of 3 over 2 divided by 1 over 2, and you have to remember, keep, flip, change, KFC, negative square root of 3 over 2 times 2 over 1. That's how we'll end up with a negative square root of 3. So 300 degrees is the magic number that we're looking for here. All right, so let's go ahead and come back over here. That means that theta is 300 degrees. So we've got what we need now. We know r is 6. We know theta is 300 degrees. So to go from this rectangular form, all we would need to do is write it as r cis of theta. So we're going to have 6 cosine imaginary sine of 300 degrees, and we have done it. This right here is what we were looking for an answer to transform from rectangular form to polar or trigonometric form. So now let me clear the screen and let's work on one more example. Okay, so our last example here, number 7 that we're going to call it, takes something that looks like this: 5 square root of 3 plus 5i. And again, they want us to go from this rectangular to trigonometric or polar form. So let's think about this one in the quadrant system. Well, the x part, the real part, is positive, and the imaginary part, the y, is also positive. So it's going to reside somewhere in here. Now, the angle that I'm describing here isn't necessarily correct, but just know that the angle is going to be somewhere right here in the neighborhood of 0 to 90 degrees. There's 0, there's 90, because we are in quadrant 1. Okay, we're in quadrant 1, so somewhere between 0 and 90 is the angle that we're going to be looking for. Okay, so what we're going to do first is we're going to find the modulus here, and we remember the formula that r equals the square root of x squared plus y squared. So let's figure that part out first. R equals the square root, and x squared in this case, 5 square root of 3 quantity squared plus 5 squared. And that looks something like the square root of 25 times 3 plus 25, which is the square root of 75 plus 25 square root of 100, which makes r equal to 10. So r equals 10. Now we have to find the angle theta, and in order to do that, we recall the other formula, and I'm going to highlight it once again, that the tangent is equal to y over x. So let's go ahead and write down the tangent of theta, in this case y being 5 over 5 square root of 3. The 5's, bring that back over, the 5's end up canceling out, they cross out. We're left with 1 over the square root of 3. And so we're looking for where in the first quadrant is the tangent equal to 1 over the square root of 3. So what we're going to do is we're going to fly over to our unit circle right over here. Let's look at this quadrant here, 0 to 90. And we're looking for some place where y divided by x is 1 over the square root of 3. Well, I'm going to point it out for you, all right, in case it's not obvious, and then you can go back and you can figure it out. It happens right here at 30 degrees or pi over 6, okay? So let's prove it. We know y is 1/2, and then divided by x, which is the square root of 3 over 2. Then when you're dividing fractions, you always remember to keep the first fraction, flip the second fraction, and change the sign from division to multiplication. KFC, as I always say when dividing fractions, always remember to KFC. And it looks something like this. The 2's end up crossing out like this, and you're left with 1 over the square root of 3. So it happens exactly at 30 degrees. That's our theta. So let's go back to our problem. Okay, theta equals 30 degrees. So now we're ready to write this in trigonometric or polar form. Now I'm going to write out the expanded form, and then we'll write the r-cis form. So this r was 10, all right, and then it's going to be times the cosine of 30 plus the imaginary sine of 30, and it looks something like that. And of course, if you write it in r cis form, it's going to be 10 cis of 30, and it looks just like that. So either way, either one of these is acceptable as the answer. So again, these are some neat examples, not terribly difficult. There is some thought process involved here, but some examples on how to go from a complex number in rectangular form to a complex number in trigonometric or polar form. So if this video was helpful, be sure to like and subscribe.